and he's going to answer math and science questions. He's more of the math side. He's very good at math. He's like a department chair of a college in Canada in math, but he's also having the support of some awesome science chads, or science gods, I say, from my server. Kato, are you gonna be the one there? Kato, are you helping out Penn Center with some of the science questions after this? That's happening in like 2.5 hours. But I know he said he had people. Okay, so let's see. What's the first question? Oh wait, let me get all my chats running. My bad. One sec. Yeah, look it up, Kato. It's cool. It's cool to watch. There is like a power ranking to professors in academia. This is also why I kind of got out of academia, because I didn't want to do the publish or perish thing. Because at that point, like, your worth as a person is really directly related to how much you publish, and I don't like publishing. I like doing this. It's almost bedtime. All good. Oh, I need to go live. Sorry, on TikTok. I'm dumb. Making mistakes today. So let me turn on air. It's gonna get hot. I can feel it. Okay. Welcome to TikTok Live. Have fun interacting with your viewers in real time. Creators must be 18 or older to go live. Viewers must be 18 or older to recharge and thank us. Remember to follow. Blah, blah, blah. Okay. So if we go to the queue. And let's go see. We already got a lot of questions up here. All right, Josh, you submitted this early. First of all, Josh is always sending things in French that I don't speak French yet. So I gotta get this translated. Sorry, one sec. Also, fuck ChatGPT 5.1. It's absolute trash. It's fucking garbage. Oh, wait. No, stop. No, sorry, just translate this. Don't do the question in French for me. Okay, there we go. This is it. Okay, a charge has a velocity of 3 times 10 to the 6, almost the speed of light. It's making an angle 45 degrees with the x-axis in the xz plane with both x and z components positive. In the xz plane. Oh, okay. So, okay, so we can talk about the movement of it, right? So, velocity of said charge. It's moving in the xz plane, which means it has no movement in the y-axis, right? So we can say that that's 0. And then in the xz plane, that means with regards to the x-axis, that's going to be 3 times 10 to the 6 cosine of 45 degrees. Or here, let's just say v naught cosine. I'm going to say v naught. Cosine 45 degrees. And then this is going to be v naught sine 45 degrees, which, lo and behold, is the same thing, because sine of 45 degrees is square root of 2 over 2. You found a 74? What's a 74? Zhang Lim Wang has an H-index of 339? Jesus. That's impressive. Yeah, someone go find someone with the highest H-index. I'm curious. And there's a magnetic field of magnitude 0.3 T. If B is directed along the x-axis, what is the net force? Okay, so this is where this comes in. So force on a charge is equal to Q, and then it's V cross B. This is, again, just more kind of like vector calc stuff. And so if B is directed along the z-axis, okay, so for question A here, yeah, 300 is nuts, dude. What? One sec. Why is my TikTok thing not connecting? You need to connect it today. One sec. Okay, it should work now. B is gonna be 0, 0, B naught. Okay, cool. Okay, so the z component never crosses with the z component. It's literally just this with this. So here you go. So V cross B. I can show the full way you do it, but you want to get good at just picking this out, actually. So this is V naught square root of 2 over 2. This is 0. This is V naught square root of 2 over 2. And then B is 0, 0, B naught. So here's a cool thing. When I do the cross product of these, right? So if I do this one, right, the x component is going to be 0. Because look at that. 0 times B naught minus 0 times V naught. So there's no x component. There will be a y component. But then there's also no z component. So this is the only component that survives. So you can just say this is equal to 0, comma, and then there's a negative here. So that's me negative V naught, B naught, and then it's going to be square root of 2 over 2. Comma 0. Cool? Nice. That's how you do that one. Wow, thanks for the follow, Bugsy. All right, so then if the force on the charge is out along the y-axis, what is the direction of B? What is the direction of B? Oh, interesting. Oh, so now they kind of do the reverse thing here. Oh, this is cool. Oh, and then, sorry, F would be equal to Q times that. Right? This is V cross B. So it's equal to Q times all that. And then, what are you doing right now? Bugsy, I'm doing a little bit of physics. I have more physics coming up. And then we are going to do math. I mean, this is math. It's cross products. B is interesting. If the force on the charge is it only across the y-axis? I'm going to assume it is. So for B, we have F is equal to 0, comma... Oh, 2.5 times 10 to the minus 3. I assume it's going to be 0 in the other ones as well. I assume it's 0. So this is actually kind of cool, right? Because we saw that this term here, when we did the y component, it came from this. It came from the amount in the x direction. So that angle is going to be with respect to the x-axis, not the z-axis. Why do you do free tutoring and then paid tutoring? Because if I just did paid tutoring, then not everyone would get help. I have to do paid tutoring because my rent is not free. No. I wish my rent was free. You're not late, Alistair. What's up? Okay. So, that's going to say 2.5 times 10 to the minus 3 is equal to Q. And then I think this is going to be negative V naught, B naught. And then whatever this was, this is... that was the x component. The x component was cosine of 45, cosine of theta. I don't know. Check the Q, Lecker. See what's in there, Lecker. Right? Okay, cool. Okay, so solving for theta, you then get theta is equal to the arc cosine of 2.5 times 10 to the minus 3 over, what is this, Q V naught B naught? Do I care about the negative? I don't think I do, right? Because whether it's positive or negative, it's still going to have an angle. Oh, but they say with the positive z-axis. Ooh. Fuck, actually, that's kind of fuck things up. Oh, but Q is probably negative too anyways, right? Yeah, Q is negative anyways. Okay, great. Love that. Okay, so yeah, we will get a positive angle. Great, okay. And then this is the angle. Skizzy, has your thing? Yes, it's in there. You're number 11, number 12. This is the angle with the plus x axis. So in this plane where this is z and this is x, right, this is theta, then the answer is 90 degrees minus theta because you want this amount, Josh. Cool. Yeah, the reason is this is the x component of B. Nice. What's the lineup? Yeah, what's up, Z-Sig? if you want to see the lineup, so anyways, this question's done, and I'll show the lineup in a second. All right, nice question, Josh. It was fun. Yeah, this goes to Josh. Mark that is done. Nicola, you're up next. Someone says, Kato says, the soundboard is so weird to me, but I bet it's like Coco Melon for the 13, 18-year-olds. Correct. I can't tell you how many like comments I get on my YouTube videos about how much they fucking love the sounds. So, it just works. I know to adults it's probably like cringe, and they're like, can you stop with the sounds? And I say to these people, you don't understand Generation Z. They need stimulation, otherwise they swipe away. So you have to hit them with the stimmies. It just fucking works. It does. That's what I say, dude. It works. Believe me. If you want something without sounds, without stimmies, go watch Khan Academy. It's great. It's great for people who are like locked in and focused and don't need the stimmies, but for the increasing majority of our population that is learning and in school, they need the stimmies. They're like cokeheads, yeah. Well, who made them that way, bro? It's Facebook, TikTok, and whatever, dude. We have rewired our dopamine experience so badly. And rather than fight it, I'm just like, just embrace it. Because you can't fight it. Who has billions of dollars to fight the billions of dollars that Facebook, TikTok, YouTube, whatever, have invested into determining how to get people hooked on stimmies? Certainly not the Department of Education. No. They're about to be, a thing of the past. Cool. Nicola says, we're doing right-hand rule for our exam tomorrow, but he said we can answer everything without knowing how to do cross products. I've been having trouble understanding it, but I don't know how much time I should devote to it. You should definitely know the right-hand rule. 100%. Let me see the question you submitted. Hello, princess. Yes, it is National Princess Day. Oh, yeah. That's too funny. All right, cool. Ooh, here's one. Forces between two moving protons. Okay, let's pull it up. Yeah, but that's the state of our world, Jorgen, You gotta just let it happen sometimes. It's like my life motto, just let it happen. All right. Why is that censored? What's censored? I don't think anything's censored. You have issues on physics. What do you think I should do to pass it? Practice. Or ask questions here. I see you have questions, Khaled. I see you're number 9. I'll get to it. Also, if people are submitting multiple questions, I will do one of yours. Just because of the amount of people that are submitting questions. I will do one. If I have time, I'll do the other ones. If I don't worry, Penn Center will be on. Let's help out Nicola here. So, 2 protons move parallel to the x-axis opposite directions. Great. At the same speed v compared to okay, great. At the instant shown, find the electric and magnetic forces on the upper proton and compare their magnitudes. Fascinating. Okay. What an ass question, by the way. Okay. So, yes, there is an electric force, or the Coulomb force, right, between these two positive charges. Cool, Sigmund. You only need the top one? Yeah. And that has to do with F is equal to K, we would say Q over whatever this is. Yeah, R squared, right? Here the Q's are the same. So it's F, K, Q squared over R squared, all right? That's the electric force because these are both positive charges. And this is also a positive charge. You don't have to use quantum mechanics for this, Leckle. And they are protons, so we assume Q is equal to 1.6 times 10 to the negative 19, right? So Q 10 to the negative 19. Yeah, I mean, E is a known constant, K is a known constant, and then R is given. Okay. Now let's think about the magnetic force. So this is interesting. This is where this is kind of a shitty question. Because what's going to happen is if this charge, Nicola, is moving to the right, it's technically creating a current. Because we learn in E&M that, like, current is equal to, like, dq dt. Okay? So the rate at which charge is moving that's equal to current. You can try to ask a short one in chat, but I probably won't get to it. If you want the best, Jesus Christ, we already have 14 questions. If you want the best chance at your question getting answered, submit it to the queue. Okay, so and they say at a speed v. Okay, so dq dt, I think is then just equal to q times v. Is that right? I think that's dq dt. Because we define current as like coulombs per second. This is like coulombs meters per second. Where's the E equals QV equals Q? Oh, is that the electric field? You may be right. No, I want the current. What's the current? Sorry. Let me just ask chat real quick. What is current from a electron moving at speed v? I think it's just the t is the time it takes to pass a point, but since it moves a distance L in TV, the current depends on how you define the length. Right, exactly. Okay, so current density, QV, that's what I was saying. So the current produced by one electron moving along a wire is QV over L, where we define the instantaneous current as QV. Okay, so it's just Q times V, right? Yeah, it's QV. Okay, right. Yeah, I know it's kind of weird units because it's meters per second, but anyways, so this creates a current, and remember, it's kind of backwards, but we define current as the movement of positive charge. Technically, negative charges, electrons move the opposite direction to create current, but we're going to define it as positive things going to the right. So this is the current, and then now you need to use, I believe it's, whose law is this? But integral of b dot dl.
Nice.
Yeah, ENM's great. Is mu naught I enclosed. So this defines the magnetic field that is produced from a current, a line of current. So in this case, your DL ends up becoming like this. It's like a circle around the wire because wires, currents of wires create magnetic fields in circular patterns around it. Kato says, I love how I found this stream by accident scrolling shorts and I watch the stream whenever it's on. Great. See, it's working. This is why. When people ask me, like, why do you stream on YouTube and TikTok vertical? I'm like, because of this. Okay. B times 2 pi r is equal to mu naught, and then the current that's enclosed in this, like, imaginary loop that I built is equal to QV, right? So this is equal to QV. Okay. So then B is equal to 1 over 2 pi r mu naught QV. So that's the magnetic field here being produced by the current caused by the charge moving to the right. Now what happens is that current, right, produces a magnetic field that looks like this. So up here, the magnetic field is coming like out of the page, which is what they draw here, right? So at this point here, we would draw that this is like the magnetic field. Below it, right? Or sorry, this is out of the page. Below it, it would be into the page like this. Now, if the B field is this way, and the velocity of this charge is this way, this charge is going to feel a charge due to the... It's called the Lorentz force, is what it's called. But moving charges in magnetic fields feel a force. And that comes from this. So we can say this is like F magnetic. I think it's technically called the Lorentz force. But this is equal to Q V cross B. Technically there's a vector on it. But I think they're just comparing magnitudes. So this is where the right-hand rule comes into play. If you want to know the direction of it. So let's see. Right-hand rule. Yeah, it's kind of whack. Dude, what? Dude, why is their finger like that? Where's like just regular ass fingers, dude? Here you go. This looks actually kind of... Well, man, this is the one I want. Okay. No, not that. I thought I copied this. Copy image. Okay. So anytime you do A cross B, the result of A cross B is always your thumb, which is this. Okay. In this case, B is V. I know it's kind of weird. So we're going to say this is V. And then... Or sorry, no. Oh, wait. Oh, whoa. This is backwards. Yo, what? No. What? This is so wrong, dude. Oh, my God, dude. What? Dude, who came up with that? Jesus Christ, dude. No. That's backwards. That's the left-hand rule, right? That is the left-hand rule. And it's called the right-hand rule. That one's wrong. Oh, man. Can I just get a nice diagram of it? This is correct? No, I don't think it is. No, it's definitely not. It's not. This is wrong. Yes. Okay. Yeah, so let's... Yeah. So let me fix this how this should be. This is wrong. This one should be A. And this one should be B. Anyways, so the first thing is your pointer finger. The second thing in the cross product is your middle finger. And then the thumb is where they go. Okay? So, yeah, but the up and down is very important, Jorgen. So, in this case, the first thing being crossed is V. The second thing being crossed is the magnetic field, which is this. And so the result of that, V cross B, will point in the direction of the force. So if we look here on our little right-hand rule, right? So V, right, is pointing this way. That's your pointer finger. B, your middle finger, is pointing that way. And so your thumb points up. And that's very important because now it says the magnetic field is in the same direction as the electrostatic force. Exactly. This is the left-hand rule, but like weird. Anyways. Okay. Let's move this. I don't... Dude, that's a terrible diagram. Who allowed this to be on the internet? Okay. So this is equal to Q. V is just gonna be velocity. And then it's 1 over 2 pi r. Sorry, let's put the B term in there. 1 over 2 pi r mu naught q v. Okay, cool. So this is going to be equal to mu naught over 2 pi. And then it's q squared v squared over r. They thought it was a gang sign. Yeah, you gotta keep like doing this. It's actually kind of fun. Okay. So then let's compare that. So this is the magnetic force. Was equal to this. And we say like, okay, which one's bigger? Well, we both have q squareds in here. This has a v squared in it. I guess the question, and this has divide by r squared. This has divide by r. So I guess it comes down to the constants. So k is equal to 9 times 10 to the 9th. What is mu naught? Is it 8.85? Okay, it's 1.2 times 10 to the minus 6. Where was it? All right, we're gonna say 1.26 times 10 to the minus 6. Okay, so here's why you can see right away, Nicola, why the electrostatic force is bigger than the magnetic force. First of all, they both have q squared, which is great. This has v squared, but we're told that v is small compared to the speed of light. And I think I know where this comes in. Because, like, mu naught epsilon naught is equal to c. Isn't that true? So watch. This is actually kind of cool. I don't think your teacher really wants you to do this, but if we did force electric over force magnetic. So first of all, k is 1 over 4 pi epsilon naught. So that's 1 over 4 pi epsilon naught. That's q squared over r squared. Divided by the magnetic force, which is mu naught over 2 pi q squared v squared over r. So let's cancel some stuff real quick. So that cancels with that. Pi cancels with pi. Yes, exactly. 1 over square root mu epsilon should be c. Yeah, I agree with that. This is where this is actually pretty cool. 1 over square root. Right, so I think mu naught epsilon naught is equal to c squared. Is that right? So mu naught epsilon naught is equal to c squared. Bresticle says, I use it in a paper on electromagnetic wave propagation for PDEs. Cool. That's really cool, man. Okay, so 1 over mu epsilon. Oh, is it 1 over mu epsilon? This is it? Let's see if that makes sense. Yeah, I forget what epsilon's 8.985 times 10 to the minus 12. Oh, 10 to the minus 12, 10 to the minus 16 is 10 to the minus 18. Which, cool, is pretty close to 10 to the minus 16, I guess. Yeah, which is wave speed. Yeah, it's pretty cool. Okay. So, 4 goes on the bottom, 2 goes on top. That's 1/2. Then you have r squared canceling out with one of the r's. So this gets you... Alright, let's see what we got here. This is 1 over mu naught epsilon naught. Right, because this is going to come down. This stays here. And then we have v squared. Right, 1 over v squared. And then there's still a 1 over r from here. Now, this is equal to 1/2. This, from Bresticle, said this is c squared. So this is c squared over v squared, 1 over r. Very cool here. Now, what they said here was that the velocity, v, was small compared to the speed of light. So they say v is small compared to the speed of light. So v is much less than c. Then c divided by v is much greater than 1. And c divided by v squared is much, much greater than 1. So this is cool. This ends up being a lot greater than 1. The radius is not really that not even that big anyways. So, yeah. You get that force electric over force magnetic is also much greater than 1. Cool. That's a super cool question. Yes, R has to be large, right? In order for them to be equal, the R has to be big. Jorgen's right. Yeah, if R was big, unless R is big, right? If R is big, then they're equal. But I think we assume the charges are decently close to each other. Cool. Does that make sense, Nicola? All of that? There's a lot going on there, I know. Yes, it does. Okay, great. I think I just discovered a way to determine concavity using the second derivative. Ooh, please tell. Okay, cool. All right. Great question, Nicola. Quick little thing, Nicola. Just like things that you should know for like your test coming up. So I'll just do real quick here. Just I know your test is tomorrow. Some like key questions that they might ask. Thanks, Trollcats. Wow, Trollcats is here at the beginning. Is they'll have like 2 wires of like different currents, and they'll ask which way did the wires move? So this is kind of an important one because each one of these wires creates its own magnetic field, and then you have to find the force on, let's say, the right wire due to the magnetic field generated by the left wire. So this one they like to ask. And then the other classic one is, it's something like this usually. And then there's like a positive charge, and then sometimes like an electric field, and then like this comes through. And then it exits sometimes into like a magnetic field that's like this. And they'll ask like what's its radius of curvature here. And then the important one for that is that, so F, which is equal to QVB, is also equal to mv squared over r. So this is like Lorentz force. And then this is like mass times centripetal acceleration. So what that tells you is that if you have a charge with an initial velocity in a magnetic field, it will continue to move around in a circle. And that motion is eventually called cyclotron motion. And you can solve for what's like the cyclotron frequency, and then the radius. They call it like the Larmor radius. That's another one. Yeah. So try to see questions like that. Yeah, right-hand rule magnetic forces and circuits, but only DC. Okay, good. Yeah, DC circuits are chill. Kirchhoff laws and stuff. Electrodynamics for Olympiads, Jackson. F equals MA. Did you know that? I did. Okay, cool. All right, I'm gonna put this. The screenshot for this Nicola will go in the in our Discord. So let's see. Let me post that. Nice. It just takes a lot of tedious algebra that takes a long time to solve for the unknown. Yeah, I understand. And again, on your exam, just make sure you at least get to the point where the algebra starts. And then if you're running out of time, say fuck it. Go to the next question and make sure you at least write down the physics. And cyclotron motion can happen with additional components of motion. Yes. Exactly, Jorgen. Yeah, that's the QE plus QV cross B. So that's when you get like a precession, which is really cool. Okay. See, Master Muguku. Okay. Is this Greek? I see a lot of omegas and like... No. Dude, what is this question, bro? What? I see so many thetas and pies. Yeah, dude, it looks like someone just like vomited like math symbols on a question. That's ancient Greek as well. Okay, whatever. Here, let's let me ask chat to translate it. And I don't like 5.1. We're going back to 4.0. I'm gonna translate this, please. Apparently, Google Gemini 3 came out today and is like super dope. I might start transitioning to it. Apparently, it's really nice. Oh, nice. You read Greek? Okay, cool. Well, here. Maybe you can help me with this question then. This looks like it's an engineering question, which I will try to answer. But again, I don't have an engineering degree. I have a physics degree, so... Where's my boy Penn? Penn will be on later today, actually. He's gonna do the cleanup for all the questions I don't answer, which is already at 14. Like, wow. You picked a great day to run a back-to-back stream. Okay, let's see. This is it. You can leave this one. Zach says you can leave this one. Well, maybe I can, actually. Should we leave this for Penn? He'd be so upset. Sigmund, when will you answer my question? When I get to it. There is a queue. Yes, for those that are watching, if you want to submit a question, the website is www.actualofficehours.com. Drop in your username, screenshot, and hit upload. If you want to see where you are on the queue, click queue. Don't worry, if people are submitting multiple ones, I'm just going to do one of theirs. So don't get too hung up on stuff. Will the next stream be able to help out with physics at all or not? I think so, because I think Penn Center has some physics smart people helping him out on that stream, which we'll see. Yeah, there. I'll shout out real quick. Penn Center. Go make sure you go follow Penn Center, because he's the one running the stream after this, and he's gonna help out with the questions. And I think he has some science people with him. Okay. Yeah, what the fuck is this, dude? What? Penn Center knows math. He knows a lot of math. Oh, Don is still alive? Don knows physics too. Is Don doing homework help? If people want to go like bug Don. Don tried to learn E&M. Wait, Don doesn't do physics. No. Don's a math guy. Where's physics and depression when you need him, dude? I hope I spelled his name right. Oh, I didn't. Oh, he's doing his own homework. Okay. All right. This is a cool question, Mugu, but I have no fucking clue how to solve it. Because this looks like an engineering systems signal processing stuff. You know, this looks pretty close to what... I was helping a student out. Let me just show you what I was doing. It looks like electrical engineering. I agree. Which, yeah, I do a little bit of electrical engineering. This is really cool. So I was helping a student out with this today. And it was designing a robot that would be able to navigate, like, this maze. And I did it with, like, FSM diagrams. I thought this was really, really cool. So this is kind of like engineering, right? So I came up with this. The logic for it is super dope. But... So yeah, I have been getting more and more into, you know, like state tables, like how to do operations and stuff. This was another one I did, like showing how two half adders can do this, and then I don't know, that does that. So anyways, yeah, there's a lot of stuff on there. Cool. But yeah, I don't know how to do this one. Not to worry though, I'm going to... What's with the hate on engineering? I don't know engineering. I never took it. But I am going to put this into our server, Mugu. So this will get sent over there. Mark it as done. There you go. And then what can happen is that if I have another person in my server who also knows electrical engineering, more than welcome to help out and maybe give like an answer. I know someone in my Discord, someone in the chat right now is like, oh, that's an easy question. I already know how to do it. Well, if you know how to do it, make sure you go to our Discord, and then in this homework help channel, there's gonna be a forum post with his question, and then I'm gonna post what I have so far for it, which is this. So at least you can see the translation probably. Oh, that's like garbage, dude. I can't even like read that. One sec. Let me fix that screenshot. Yeah, you're more than welcome, Mugu. Yeah. We got a pretty cool community. I have a lot of really smart people. I'm blessed to be surrounded by so many awesome smart people. Which, speaking of smart people, let's give a shout out to Zach. Nice. Zach is a math god. But yeah, if you ask a question and I don't know how to do it, more than likely Zach knows how to do it probably. Or Obi. Obi knows. Yeah, what's up? Obi's another great math god from across the pond. So yeah. Make sure, yeah, go join the Discord, actualofficehours.com. Click here, join Discord. Go and get help. Don't say that, Actual Education. You're very smart, dude. I'm gonna gas you up, dude. All right, let's see. Next question is from Alistair. Love this. This is physics. Al Pastor. I like Al Pastor. 100 joules. Thank you, Machka. Thank you. We love the jewels. Run the jewels. Okay, here we go. This is some physics. Given M1 is equal to 6 kilograms. There's a picture with it too. Oh, sorry, did I not see that? Where's the picture? Oh, that would be useful. Yeah, let's grab that. This is a great question. If anyone is here from my mechanics class, yeah, this is a mechanics question for sure. Okay, determine if the system will move and the acceleration of the system and the tension in the string. Great. All right, so when this happens, I like to draw force diagrams. So, I'm trying to think if... Yeah, I should just make a new diagram, right? I already know what this looks like, so... Just because yeah, let's do it this way. I'll just redraw the diagram. What problems do you struggle more with? Anything like engineering, I just literally can't do because I don't understand the jargon. There's a lot of like weird jargon in engineering. Struggle with and like I can do like diffie-q these days, or linear algebra. I sometimes struggle with linear algebra for sure. Stuff I literally can't do that's like discrete math. And that stuff I pass to Zach and Penn because they're much smarter at math than I am. Quantum mechanics sometimes gives me a rough time too. Okay, so Alistair, let's talk about the forces. So M2 is 8 kilograms. M1 is 6, and then we have mu s and mu k. Okay, cool. And I assume, yeah, mu is referring to this. Okay. So, let's think what's going to happen here. For M1, I'm going to have a force of gravity pulling down. And that's going to be equal to 6 times 9.8. Actually, let's leave everything as variables. So, M1G. And then if this is theta, this can then be broken up into components. Whereby... there's a website. I sound like Tony Soprano. There's a website, www.actualofficehours.com. It's linked. It's right there on the stream. You should see it. Okay. So this is like the y component of gravity, and this is going to be equal to m1g cosine theta, and then this is the part of gravity that's trying to pull this thing down, and that's going to be equal to m1g sine theta. And then, sir, any advice? I'm studying and nothing is sticking. Ooh. Maybe things are sticking, but you just don't think they're sticking. How are you studying? That would be my first question. Are you just reading stuff? You just read stuff. Nothing really sticks, honestly.
That's dope.
But if you do practice problems, it does. I think everything sticks if you do it. All right. And also, there's rope on this. And the rope is probably going to pull it this way, right? Writing and doing questions? Yeah, that should work. If that's not working, I don't know. Are you doing AC analysis? Oh, well, okay. When you're doing questions, are you just mechanically doing the questions? Or do you understand the steps every time you do a question? I think that's the important thing. When you're doing questions, you need to understand like why you're doing things. If you're just a robot like writing numbers and copying solutions, you're not going to learn. Go. So, yeah, make sure you understand, like, the steps. You do it step by step. Do you understand every step, though? And, like, why you make the step? Okay. Alright, this is my force diagram. This is without friction. So, I think what I want to do is figure out, first off, whether this thing is going to fall this way or fall this way. Because then that tells me what friction needs to do here. Right? Do I have any videos on work, power, and energy? I kind of... yes. I do on power and energy, for sure. No, I do on energy. I mean, power is just the time derivative of energy, I guess. Where's the masses? Well, here's M2. This is M1. We haven't put any values in. We're just going to leave it as variables for now. And then... Okay. Let's define... Well, let's look at some stuff first off. I want to see if the force of gravity pulling this down beats out the tension in the rope that's trying to, like, pull it up. I'm pretty sure it doesn't. Because, first of all, this thing is less heavy than this, and it's also at an angle. So only part of the gravity really pulls it down. Whereas this thing has all of the gravity pulling it down. So I think we can assume... And he's back. He is. I think we can assume that this thing is going to fall this way, right? And what that means then, okay, is that friction is going to oppose that motion. So let's put a force of friction. I think M2 definitely goes down because M2 is heavier and M2 is not on a ramp. When things are on a ramp, they don't really want to fall down as much as if they're just, like, free falling. Hey, I'm doing this right now in physics. Haha. That's the algorithm for you, dude. TikTok monitors what I say. And so if I say, like, things related to a mechanics question with blocks, it starts showing my videos towards people who do that. Okay, so then this is going to be the force of friction. Yes. Well, FG minus FF. So, tricky. You gotta be careful here. Because technically... So, friction always opposes the direction where something wants to go. Because M2 is connected to M1 and M2 is heavier, it wants to pull M1 up. And if it wants to pull M1 up, then friction needs to oppose that. And friction now points in the same direction as gravity does. What's the question? If you ever want the question, just go to the queue, and then it's in there. You thought it was mg sine theta? Yeah, this is mg sine theta. That's the component of gravity that points in the direction pulling it down. Exactly. So, yeah, Jorgen, we are going to do that. So, here's the key thing, is that if the force of friction... The maximum force of friction, which is related to the static coefficient of friction, if that friction is enough to fight off the tension from this thing trying to fall down, then nothing will move. It's actually really cool. You think friction points... Yeah, down. Yeah, I agree. What app is this? Oh, it's just a whiteboard app. Okay, so now I like to talk about, like, the overall movement of this entire system. So this system wants to move this way. I'm going to define this direction as negative. This direction is positive. So when I look here, specifically, right, this thing moving down is technically going to be positive here, and this will be negative. This will come into play when we talk about sum of forces. Yes, tension is always parallel. In this case, right, if this is negative, that means this is positive, okay? So now this direction is up. Okay, so let's write out the sum of the forces for everything, right? So let me do sum of forces for block 1 in the x direction. So you're going to have tension pulling it to the right minus m1g minus the force of friction, okay? Because those are the two things that are trying to pull it down to the left. This is the only thing trying to pull it up to the right. And then the sum of forces on block 1 in the y direction, that's this way, y direction. That's going to be Fn1 minus... sorry, this is m1g sine theta. I wrote this wrong, sorry. Sorry, this is m1g cosine theta. All right, let's see. All right, now let's do the sum of the forces. And then, again, this is also equal to, all of this is equal to MA. So in the x direction, sorry, this is equal to M1A. Here, this is equal to 0, because we assume the thing is not accelerating vertically on the plane. I don't have time to create, or I can try. Yes, no, I thought you said, can you create a physics problem? Yeah, I can definitely, submit it to the queue. All right, sum of forces on the second block in the x direction. Well, that's 0. Oh, wait, but actually, ooh, we have to be tricky here, actually. Yeah, because the directions actually kind of matter. Yeah, okay, I'm going to do this later. I'll show this. Okay, sum of forces in the x direction is equal to 0, but the sum of forces in the y direction, okay, that's going to be m2g being positive, because we said going down is positive for this block, minus the tension. And then this is equal to m2a. The timer says this goes for another hour and 43 minutes. And again, if you want to figure out all the times we stream, the website actualofficehours.com, if you click here on the streaming schedule, you'll get a beautiful calendar of all the times we stream and all the times our awesome, amazing friends stream. So, if you have more questions about math, Zach's also doing a math stream Wednesday morning. And then Penn Center will be doing homework help all the way until 10 p.m. tonight. So after our stream is done, we're going to go raid Penn Center on Twitch. And he's going to keep going through your guys' questions till like 10 o'clock. This is a great question, right? Isn't it? Yeah. Who asked this question? You, Alistair.
Good job.
Yeah. And then, yes, Leckel can help with quantum. Okay. Now, here's the cool thing. Movement in this direction is the same as movement for block 2 in the y direction, right? Because the amount that this moves in x is the same amount this thing moves in y. So these accelerations are the same. Technically, this is A2 and A1. But then, because they're held together with a rope, any acceleration here is also the same acceleration here. So we're going to just write that as just A. And then, let's see. They want the acceleration of the system. Okay, so I need to use these two equations then, right? So let's see what we got. This is the hardest thing. In physics, this is the hardest part. Once you have this set up, it's algebra. Exactly. So let's add up this one and this one, for instance. So I'm going to get T minus M1G sine theta minus force of friction is equal to M1A. And then here we're going to get M2G minus T is equal to M2A. All right. So then we can then add these two together such that the plus T and the minus T cancel out. And I'm left with just M2G minus M1G sine theta minus the force of friction is equal to M1 plus M2 times A, right? Because I just grouped this. And now this is going to be my expression for A. Okay, but now we need to figure out the force of friction. What's up, 1K? So force of friction... Wait, go over. And don't worry, all these things are recorded too. So all these lessons we do are recorded on YouTube. So make sure, if you go to the website, go watch us on YouTube, give us a follow. Also, go watch us on Twitch. Twitch is a much better way to watch this stream because it's horizontal. But we do it vertical for the discovery. What's the YouTube account? Same website, just click there. Click on visit the YouTube. It's right there. All right, force of friction is equal to either mu s or mu k times Fn1. And it depends whether it's stuck or not. And then how do we get Fn1? Well, we get Fn1 from here. So this is actually kind of the cool thing. So from this, you can now say that Fn1 is equal to m1g cosine theta. So then force of friction, let's say for instance let's pretend it's stuck. Let's just see mu s. Let's say mu s m1g cosine theta. And I think what I should see if it's stuck is that the acceleration should be 0 or negative. Right? And if it's not stuck, then I need to use mu k. Yeah, the pre-roll ads, yeah, but they only happen once. I don't run any ads during the stream. Again, that's a requirement. Twitch requires us to run some sort of ads on it. Yes, if it's static. So actually, here's actually the cool thing we can do, right? No. So we could say that the acceleration is 0, right? Let's pretend the acceleration is 0, because that's what happens if it's stuck. And let's see what force of friction would have to be, right? I think that's the appropriate way to do it. So here, like, consider A equals 0, aka it's stuck. And then let's see what the force of friction would have to be. So that means that goes over. So okay, so that means force of friction is just equal to m2g minus m1g sine theta. Yeah, but I don't want to do the ads in the middle of the stream, Kato, because what if it's somebody's question and then there's ads like while I'm helping them? That's why I don't want to do that. I agree. I hate the ads regardless, but this is the world we live in. Okay, M1 is 6. Let me just get all this information down here real quick. All right, where's my calculator? There we go. Okay. Exactly, yeah. I could pause the stream. You're right. I could do it. All right, so 8 times 9.8 minus 6 times 9.8 times sine of 40, right? Okay, so that means 40.6. So that's the friction needed to stop, to be stuck. So let's see if that's even possible. So remember, force of friction, right, is equal to mu s m1g cosine theta. So if we do, and m1 was 6, so 6 times 9.8 times the cosine of 40, that's equal to 45. So this is equal to 45. Okay, so I don't think it works, right? Because mu s, but friction can, at max, provide, what was this? This is 0.25? Not very much, right? So that's 11.26. Not gonna work, right? So it's not stuck.
No.
Okay, so that means we have to use... So we must use kinetic friction, UK, which is equal to 0.15. All right. So now, my equation here is 0.15. And then this is times... That mg cosine theta we got was 45. If they intersect at any point, you compare the components. You solve x1 equals x2, y1 equals y2, z1 equals z2, and then see if you can get a value of t where that happens. Or you can do like, sorry. Yeah, if you want to see if they collide, it has to be the same t. Otherwise, you put like a T1 on all your and then you put a T2 on the other one, and then you just see if there are solutions T1 and T2 that make that happen. And sometimes they don't. In Seriner, yeah. All right, so this is 8 times 9.8 minus 6. Oh, TikTok doesn't think we're real. I gotta solve a CAPTCHA. There we go. Yeah. If you want to drop an example question of that in Cerner, that's a fun one to go through for sure. I just did that with another student. All right, let me figure out the math for this. 8 times 9.8 minus 6 times 9.8. And then skits, no we have not. Sine of 40. Okay, and then minus 0.15 times 45 equals that. And then divided by m1 plus m2, so divided by 14. Cool, acceleration is 2.41. Yes, I will, Khaled. I definitely will. I'm only doing one question per person. Okay, there you go. That's the acceleration. And then if you want the tension, and that's, you know, clockwise. And then if you want the tension, just to save time here, just plug it into this. Right? Here, plug it into here. No. Okay. For A, so for tension, plug in here. Solve for T. Nice. Okay, cool question, Alistair. I like that, dude. It was fun. Thank you, Fembox. Yeah, Fembox. Fembox doing the mostest. Answering questions in the chat. Appreciate that, Fem. Smart goes done. Jorgen says tension in this case is equal to M2G but parallel throughout the string. I don't think it's equal to M2G because the acceleration is different. If the acceleration was 0, it's equal to M2G. Oh, did I not save this? Okay, there we go. Alistair. All right, let's see. What do we got next? Yeah, you're good. You're good. You're good, Jorgen. Thor. Ooh. Oh, wow. Okay. Vector calculus. Thank you. What's up there? I know this is always Sam. Thanks for the hydrate. Yeah, the net force on it, yeah. Okay, 2 vectors. Find a vector P parallel to V and a vector N orthogonal to V such that U is equal to P plus N. Make sure to explain why the vector P is parallel to V and why the vector N is orthogonal to V. Depends on the electronics, Ahmed. Is this like the orthonormal basis question I saw that came up once? P is parallel to V. Dude, we did this one. I know I did this question. Okay, one sec. All right. Yes, you can't. There's a smarter way to even do this. So if this is V, right, and P is parallel to it. Oh, amplifiers? Yeah, it's a bunch of just questions you have to memorize. Okay, P is parallel to V, and N is orthogonal to V. Okay, but if N is orthogonal to V, and V is parallel to P, then N is orthogonal to P, right? And then U is equal to P plus N. And so this is U then, right? Oh, the course wasn't in French. That was French. Okay. Oh, and then they give us U, and they give us V. Find the vector P. Find a vector P. So I'm looking for this one. And I'm given this, and I'm also given this. But I'm not given N. Man, what's the shortcut to this? Oh man, it's escaping me. U is U is equal to P plus N. P dot N is equal to 0. Wait. Okay, wait. I think I remember this. V dot N is equal to 0, right? Oh, and it's any vector, right? Oh, okay. So I think I find any vector perpendicular to, oh man. There we go. Jeff, that's it. That's what I wanted. Yes. U cross V gives you a vector perpendicular in the plane of U and V. Uh-huh. Okay, wait. U is equal to P plus N. N cross U. N cross U cross U. Yes, so because N cross U gets me like a bunch of perpendicular vectors, right? But then if I want the one perpendicular, right idea, wrong. Wait, N cross V. Okay, sorry. N cross V cross U.
Disqualified.
Oh, I know this one. I've done this one before. I hate this one. Like, dude, Jeff, chill.
Oh shit, not good.
Jeff, what? Dude, what? Make up your mind, dude. What? U cross V cross V. U cross V is equal to N. Is that what we're saying? Yes, I know what U dot V is. Yeah. Oh, that's it. It's like the projection, isn't it? Yeah, wait. U dot V is equal to UV cosine theta, right? Okay. And then the angle between U and V is the same angle between U and P, right? I think. Yeah, U dot V over magnitude of V is equal to magnitude of U cosine theta. But then I'm trying to get P. Oh, wait. U cosine theta is equal to P, right? Or is equal to magnitude of P? Yes. Yes. The component of U along V. And that's called the projection, right? Isn't that called the projection? Yes. Yep. Projection. Yep. It's called the projection. Yeah, I remember that. So that will be equal to U dot V over V times V hat. Yes, it was challenging.
Yeah.
Well, it was just kind of tedious, Alistair. Right, which is this. But then how does that help us out? How does that help us figure out P though? Oh, because if it's parallel to it... This is theta, right? P will be V plus that. Let me see. I understand why that is. I always like to draw pictures. Sorry, okay. This is theta. This is also theta, right? So U dotted with V gets me the amount of U. Yeah, is UV that U cosine is equal to U magnitude of U cosine theta. And magnitude of U cosine theta is equal to the projection of U on V, which is U dot V over V parallel V hat. And V hat, wait, P will be V plus that? It's either if you use the other definition of a dot product. Which one, Breasticles? Yes, yeah. I will do that eventually for this, for sure. Because I needed, yeah, okay. We can just get U dot V real quick, right? We are going to need that. U dot V is equal to 3 times 0, so that's 0, plus 6 times 2, which is 12, plus 2 times 2, which is 4, equal to 16, right? Oh, systems of equations for the n vector. Oh, I think you're talking about like maybe for the cross product. Right, because if they're parallel, right, then P dot, we don't know n, but ABC, yes. Yeah, that's another way to do with it. Yeah. That's the way I like to do it. And let me get like all the magnitudes, right? Magnitude of u, because I think I need them eventually. Magnitude of u is equal to 9 plus 36 plus 4. So that's equal to 7. Yeah, I think that's another cool way to do it. There's this smart way to do it with, again, drawing the picture and just seeing like one is 1 plus the other. But then you can also kind of just brute force the algebra. Magnitude of v is 2 square root of 2 then, right? Because P dot v has to be equal to magnitude of P times magnitude of V. And you don't know what P is. But I remember this becomes kind of a mess because this is like square root of x1 is like P1 squared plus P2 squared plus P3 squared. And then this is like P1 V1, well, it's P1 times 0 plus P2 times 2 plus P2 plus P3 times 2 is equal to this. Magnitude of v is equal to 7. It's not entirely easy. So what you get, yeah, 2p2 plus 2p3 is equal to 7 square root of p1 squared plus p2 squared plus p3 squared. And then if you wanted to figure out n, well, you know v dot n is equal to 0, right? But now you don't know n as well. So wait, that's another variable you have to deal with. I don't think you want to do that one as well. Dude, I'd be cooked on this one too, right? Because then v dot n is equal to 0, but that's. Oh wait, and I got this wrong. Wait. This is not. Yeah, this is p dot. Okay. So then that's 2n2 plus 2n3. Wow, thanks for the raid, Don. Is also equal to 0. But you're still solving for n2, n3, p1, and p2, and p3. Just learned Bernoulli's law. Nice. Yeah, big shout out to Don. How's your homework, Don? I heard you're doing some of your grad school homework. What if this vector wants to steal the moon? The cat jumped over the moon. Dawn left us to the void. Oh no, Dawn. Ugh. Okay. Edmund says, yo, bro, remember I told you my last calc test was today? I got a 95? Nice, dude. Proud of you, Edmund, dude. Great job, man. Redon says, got the highest score, 80, 100 in the group engineering physics. Dope. Good job. These are all great things. I'm glad you're all doing well. Uh-oh. My TikTok connection's dying. Come back, TikTok. Don't lag. Don said it was good. I wrote code that simulates hurricanes. Whoa, that's sick. What are you writing in Python? Yeah, let's not do this way. This way sucks. What's up, Legendary? Yeah, Python. Do you find ChatGPT is an absolute godsend for writing Python these days? I find it does. Ugh. Okay. I think we were on the right path here, right? We want to do projections. So, P is equal to the projection. So it's the amount of U projected onto V. So we say like this, proj V U. And so that's going to equal U dot V over the magnitude of V. And then I don't think it's... Is it V hat? But I don't want to do things with V hat. So let me just do it as like V dot V. In the V direction. Right, that's where this comes from, right? You can say this is the same thing as like magnitude V squared V. I tried to troubleshoot a library I want to use set for PyTF. Yeah. Dude, you should really try using ChatGPT for code, dude. It's absolutely insane. And again, I don't tell Chat to just write the code and I dump it in. I tell Chat to explain what it's doing, and it really helps with the jargon and the syntax. Okay, so this was 16 over 8, and then V was in the 0, 2, 2 direction. Oh, so this just equals 4, 4, right? War is over. Haha, I love math, but I feel like I need a break now. Yeah, we're gonna do some physics after this. Okay, so that's vector P. Okay, now we gotta go find vector N. Oh, okay. But P plus N equals U, right? P plus N equals U. So N equals U minus P. And then U was 362. What's up, 23 Pro? Good to see you, dude. Can you explain how to find some matrices that lies given CA and NA? If you submit a screenshot of what that looks like, I can take a look at it. So this is 3, 2, negative 2. Okay, so we found N. Oh, so we're good. Oh, so we're done, right? Wait. The vector P was already done. This is easy, right? This is vector P. I don't know if those bots work, 23 Pro. Okay. And then if you want to, yeah, N dot V should be equal to 0. And you can check that. So 3, 2, minus 2. I had stream elements set up, but I don't think I have it updated. Dot that with 0, 2, 2. Oh yeah, look at this. This is 0 minus plus 4. Minus 4 equals 0.
Good job.
Cool. So that means N is perpendicular to V. And then we already know P is parallel to U. Sorry, P is parallel to V because we did the projection of U onto V. I guess you could do a cross product if you really wanted to. Yeah, okay, cool. I'm going to say this question's done. Cool, Thor. Alright, nice. Thor!
Well done! Well done!
I've been given that exact question before. I know I have. Okay, let me see. What do we got in the queue? Ooh, wow. Design a counter that goes through the sequence 1, 2, 1, 4, 3, 6, 2, 5, and repeat using a D flip-flop for A, a JK flip-flop for B, and a T flip-flop for C. Sorry, what? I mean, this is kind of related to what I've done before, but sorry, what's A, B, and C? And what's a D flip-flop versus a JK flip-flop and a T flip-flop? I like almost know enough to do this. I know state diagrams. I know how to use what I consider, I think, just a memory unit, which is a flip-flop. And then, man, what are these sequences? Okay. I'm gonna put this straight into our Discord to see if a double E major wants to take a stab at it. Jacob. That or ChatGPT in 2 days will always look at anything that has been answered, and it'll give a solution for it as well. I've built like a bot for that. All right, Odin Root, what do you got for me? Green's theorem. More math. I know we said we're doing more math. Outward flux of the field. Y sine Y, 2x cosine Y. What is this? Y sine Y. X hat plus 2x cosine Y. Y hat. Over the square in the first quadrant cut by x equals 1. X equals 1 and y equals pi. So this is 1 and this is pi. Let me remember Green's theorem. Something over domain. What's Green's theorem? This is a Calc 3 concept. It's super useful, actually. It tells me that the contour integral around a shape is the same thing as the area integral over the shape. I forget how this works for, like, flux, though. Yeah, this is where this comes from. Where does this come into play for, like, the outward flux? Calc 3 is really interesting. I really like Calc 3, honestly. Yeah, this is Green's theorem. But, wait a minute. There's something with the field here. Outward flux. Yeah, okay, it's the flux form of Green's theorem. This is what I wanted. Okay, there we go. Oh, okay. And actually, this is the physics application of I think Ampere's law. Isn't this the B dot dl is equal to mu naught I? Okay, this is, I think, the form I want of it. F dot n ds is equal to the domain of p of x px qy dA? Bresticle says the integrand of the surface integral would be the flux density. So you just have to evaluate the surface integral. Okay. No, dude, Green's theorem is super useful. Calc 3 is amazing. Yes, it unlocks so much interesting, yeah, math, physics stuff. Yeah, look, dude, look how cool this stuff is. You guys don't think this is cool? I think this stuff is dope. Calc 2 is hell on earth. It's not that bad. It's not that bad. Okay. So I think we just have to do, so this right here, this is P. This is Q. For pre-calculus, probably a textbook. I think a textbook and going through problems is great. Khan Accounting probably has some good, like, practice questions. PX is equal to DP DX. Well, that's equal to 0, no? There's no X in here. And then QY is equal to DQ DY. Sorry, let me get that back. Okay. And that's equal to negative 2x sine Y. Right? So then this integral is now going to be, and then we're going to say like dx dy. X is going to go from, luckily it's a rectangle. X goes from 0 to 1. Y goes from 0 to pi. And then that's 0 plus this, so just negative 2x sine y, right? It's actually not too bad. Oh, no. I have a pen. Yeah, dude, writing this with a pen, dude. That'd be impossible with a mouse, dude. What? Balance a chemical equation. I do lots of videos of those. I have a lot of videos of those on my TikTok. All right. First integral is dx. Integral of negative 2x dx. So you ignore the y because that doesn't depend on x right now, and so that just becomes x squared over 2. So then you have negative 2x squared over 2. So it's just negative x squared. And then that's evaluated from 0 to 1. So it's just negative 1, right? So I just have negative sine y. dy. And so what's that? Integral of negative sine is negative cosine. From 0 to pi. Sine cubed of x is 3 sine squared of x cosine of x. Positive. Wait. Yeah, sorry. The derivative of sine is cosine. The integral of negative sine is cosine. Yes, because derivative of cosine is negative sine. Thank you, Fem. Okay, cool. So then this is negative 1 minus... Wait. Cosine of pi is negative 1, right? And then I do minus 1. So it's equal to negative 2. So I guess the flux is negative now. Did I do that right? I think so. Okay. Cool. So yeah, I think the answer is just 2 then. Okay, cool. Nice. Good question there, Odin. All right, we're going. We're moving. We got an hour. I'll get through them.
Well done.
I always have to. It's funny how many forms of Green's theorem there are, right? Yeah, the differential forms don't pop till upper level physics, but it's in the process of deriving PDEs for Green's theorem. Oh, very cool. All right, let's see. Alistair, I already answered yours. I'll come back if I have time. Let me have about Khaled. Cool. Love this. Let's do this. Thanks for waiting, Khaled, by the way. Okay. Find the center of the radius of circle C. Okay. So this is completing the square. Because you're trying to get it from standard form into like kind of like vertex form. So I'm going to group stuff. So I have x squared minus 2x. And then I have y squared. And then I have minus 15 and then like equal to 0. All right, so this right away is the same thing as y minus 0 squared, right? That's kind of nice, yeah? This one's not too bad. So completing the square, you always take this. You divide it by 2. So that equals 1. You square it, and then you do plus 1 squared minus 1 squared. And then this whole thing here becomes x minus 1 squared. But then don't forget, you still have a minus 1 from here, right? Minus 1. And then that is plus y minus 0 squared minus 15 equals 0. Yeah, you don't have to split the 15. So then you just move all these over. And you get your final thing here, which is x minus 1 squared plus y minus 0 squared is equal to 16. Which you know is a circle centered at 1, 0 with a radius of 4. Oh, I see. Yeah, that would work too, Alistair. Right? Because it's x minus h squared plus y minus k squared is equal to r squared. Okay. Find the coordinates of the points of intersection between circle C and line L. What, line L is y equals negative 1/2 x plus 5/2. It's kind of ugly.
Get out!
Oh, man. I mean, I know I have to just plug it in. I just don't want to. Fine. Yeah. There's a bunch of different ways to complete the square. Fuck. Alright, I guess I gotta do it. Okay. So, intersection. If y is equal to negative 1/2 x plus 5/2. If there's an easier way, someone tell me. But I'm pretty sure you have to just plug this into here and then sub. So that's x minus 1. Yeah. I think it's what I have to do. Unfortunately. Right, Machka? Is there a way to make this nicer though? Let's try to be smart here. Because I can multiply everything by 2, right? So then I get 2 is equal to negative x plus 5. Maybe this is nicer because there's less fractions. Sorry, 2y is equal to negative x plus 5. So x equals 5 minus 2y. Is that nicer? Maybe it is. I guess I only have to FOIL one thing now, right? So 5 minus 2y minus 1 squared plus y squared is equal to 16. So that's 4 minus 2y squared, which is equal to 16 minus 16y plus 4y squared plus y squared is equal to 16. Ooh, 16's cancel. Love. What's that? 5y squared minus 16y is equal to 0. Pull out a y, I guess. Y. 5y minus 16 is equal to 0. Okay, so then you got your coordinates, right? Y equals 0 or y equals 16/5. And then you can plug them back into here to go figure out what x is. That's actually kind of cool. If y equals 0, does that make sense? I guess it does. I was lagging in Discord. My bad. I don't know. The internet sometimes struggles. Or your internet is trash. That is true. Oh, and then part C, dude. Dude, this is... Find the area of the triangle whose vertices are the center and the intersection points between C and L. Stop. Why? This started off as such a nice question and then instantly got really hard. Shit. Okay, whatever. I have to figure this out. Okay, so I need points now. Okay, so when y equals 0, that means x equals 5. Right? And then y could also equal 16/5. So what? That's x is equal to 5 minus 32 over 5? Dude, that's so fucking ugly. X is equal to negative 7/25. Okay, let's draw the circle. Oh, the tedium. I agree, Machka. Well, it's centered at 1, 0 with a radius of 4. So that's here. And okay, whatever. Let's just say this is the radius of 4. So then this is 5, 0. And this is negative 1, 0. And then the other intersection point, 7/5. Did I fuck up, Jorgen? I did. Thank you. I did. Thank you. I don't know why I wrote 25. Thank you. All right. So y equals 0, x equals 5. Oh. So this is one of the intersection points. And the other one is negative 7/5. Wait, how can that happen though? That's outside the circle.
Get out!
Sorry, it's not negative 1. It's negative 3. It's a radius of 4. Okay. Yeah, I was getting a little confused there. So wait, the other one's like up here? So then I need this triangle? I guess, right? Well, I already know the base. So now I just need the height. Oh, this is actually pretty cool. Isn't this the height? Correct me if I'm wrong, right? For an obtuse triangle? Is this not the height right here? And then this is the base? Yeah, okay, cool. So I think I just do, so area is equal to 5 times the height, 16/5, times 1/2. So that's 16, no, yeah, 1/2 base times height. Is it just equal to 8? Fembox? You got 32 over 5. The base is 4. The base is 4. You are right. Sorry. This distance is 5. This distance is 4. So good. Thank you, Machka. Okay, cool. So that's 64 over 10, which is 32 over 5. Unit squared. Nice. Cool question, actually. Wow, I actually like that one. Cool question, Khalid.
Well done.
Nice. Fem is always my guardian angel here. Watching over my algebra mistakes. And also just when I just get absolutely like overwhelmed by a question. Okay, Skits, you're next if you're here. You still watching Skits? So I gotta like teach you guys how to rotate photos. Okay, yes, no, please post it. Yeah, can you, Master Maguku? I would love to see the solution, so please post it in the post I made. I'll also give you credit for it. I'll give you a bond coin for it. I want to see what the answer would have been. If the screenshot is sideways, the problem gets skipped. Is it worth pursuing a physics degree? I mean, I pursued a physics degree. I'd say it's pretty cool. Doesn't afraid of anything. I wonder if I need the diagram for this. But maybe we don't. Let's just call this ship A, I guess. Fuck it. And let's say A has coordinate 0, 0. B is 600 north. Okay, so this will be B, which is going to be 0, 600. Ship C is 800 from ship C on a bearing of pi over 9. Ooh. Okay, now what's bearing again? I don't think it's too hard. Depends what type of research you're trying to do. Also, like, what your connections are. It helps to definitely have connections. Sorry, what's bearing? What is that from north? Is that from... What is bearing angle? Oh, it is... Okay, it's clockwise from north. Okay. Ooh, baby, it's my favorite live. What's up, Dawn? Dream of Dawn. This is such a nice live to chill in. I agree. Yeah. Sit down. You know, there's charcuterie and, like, sandwiches. There's drinks in the back. You know, we have some cigars on the table if you'd like to just kick back and just listen to some smooth math this afternoon. If only. This music kind of sounds like it would be, right? Sounds like we're in kind of a cigar parlor or something, right? Okay. This is theta. And it's 800. So it's like somewhere over here. So this is going to be in the x direction. That's going to be 800 sine of pi over 9, comma 800 cosine pi over 9. Math tutoring club with charcuterie? That would be dope, right? All right, I'm going to do 8 hours straight of good luck with it. Selena, my calc class is so chill and lit, except everyone just makes 6-7 jokes all the time.
That's dope.
Oh, no, the 6-7 jokes. I'm so sorry, Selena.
Oh no!
But I'm glad you're getting that as your class shirt. That's at least funny.
No!
Yeah, I'm pretty sure they draw the thing for us too. Yeah. So here's my question, Skitsy. Do you know about sine and cosine? I forget what grade you're in. Boom, 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 boom. Six, 7. It's the most beautiful explanation of just like memes just appear sometimes. Okay, send the diagram. You're also doing A levels. That's cool. What's up, X-Man? They are cool. I like the daily integrals thing for sure. But as you can see, I already have like so many questions that come in. I have no time to do daily integrals as well. Skits, are you sending me another screenshot or something? But okay. This is correct so far. These are the coordinate points. So when they say find the distance from B to C in meters, okay. So here for part A, that's just going to be the distance formula. So you do the distance of this minus this. So that's 800 sine of pi over 9 minus 0 squared plus 800 cosine of pi over 9 minus 600 squared. Just sent it? All right, let me see. Yep, cool. Got it. Okay, I'll get you. Yeah, okay. What if you had a smoke ring and a superfluid and you accelerated the fluid? Wait, what? Jorgen, what?
No.
What? Wait. The bearing of ship C from B is theta. Find the angle of theta. Okay. So they want you to find this. I think this is using law of cosines. This is actually really cool. So you get this amount right here. What is BC equal to? Do I have to go do this on my calculator? I really don't want to. Can you just give me the number? Or I'll go fucking do it. It's fine. Oh, it's basically 200. You got it. I got it. BC is equal to 200. Okay, 200. Okay. This is a beautiful example for law of cosines. Right, this is 200. I'm going to figure out what this angle is. That's fine. We'll do it by doing law of cosines. And so what that says is that 800 squared is equal to 600 squared plus 200 squared minus 2 times 200 times 600 times the cosine of theta, right? And that's what this angle is. This is theta. Let's call this like theta B. Or let me call it phi. Do you know this equation, Skitsy? It's a pretty good one to know. Use the sine rule instead? Yeah, you could use the sine rule as well. You want to use sine rule? Yeah, let's do sine rule. Fuck it. Yeah, that works too. So you're going to say sine of phi over 800 is equal to the sine of pi over 9 over 200, right? So, 4 sine... Actually, wait a minute. I don't think this is 200 actually. Because I just realized I did this in degree mode. Yes, BC is wrong. Yep. BC should be 312. Which is weird, dude. It comes out to almost exactly 200. Yeah, it's 312. It's because I had it in degree mode. Dumb. Okay, 312.88. Okay, that's what I wanted. Sorry. It was super nice. It came out to almost exactly 200. I was like, wow, that's actually really nice. Okay, now we can figure it out. So, sine of pi over 9 divided by so you get sine of phi is equal to 0.874. So then phi is equal to sine inverse of that. And that's equal to 1.06. Charlie, what's up, dude?
Oh, yeah.
1.06 radians. Which, if you do 180 over pi, that's equal to 61 degrees. Okay. But that doesn't make sense. And this is where, like, the law of sines can fuck up. Right? Because this has to be an obtuse angle. Yes. Yeah. So if this is 61, well, here's the funny thing, right? If this is 61 degrees, which is not, right? It's 180 minus 61, but then in order to figure out that, I'm going to do 180 minus that as well. That just really means this is 61 degrees. Yeah, so I have a video on this. I'm going to show you. It's on my YouTube, actually. Yes, it's the ambiguous case. I'm going to show you. So, here. If you want to go watch my video on this, let's consider what happened, right? There's the ambiguous case with law of sines, where if you're taking the law of sines with an obtuse angle, so an angle greater than 90 degrees, you will not get that on the calculator. And the reason for that is arc sine is only defined in these two quadrants. It's only defined from negative 90 to 90. So, like, physically, you can't get angles greater than 90 degrees. But if you look at this triangle, like, this angle has to be greater than 90. So, again, here, go watch this video, Skits, or actually, I have it also on my TikTok. It'll explain, like, because it is a common thing that usually gets mistaught or misunderstood. Where is it? Law of sines in the ambiguous case. Go watch this. It'll explain to you, like, what's happening here. So, you got 61 degrees for this angle, but that is so wrong. It can't be 61. Right? Because this angle is opposite the largest side. And the largest side of a triangle has to be opposite the largest angle. If this was 61 degrees, then somehow I need these two to also, like, eventually add up to 139, right? In order to get 180 for a triangle. And that's impossible.
No.
You can't have this be the biggest side, but also not have the biggest angle. So, this angle is actually equal to 180 minus 61, which then equals 139. Or sorry, 119. Okay? But they want this angle. And if this is a straight line here, Skits, and this is 119, then this is 180 minus 119. So it's the original 61 you had anyways. Yeah. If you had just stopped here and just said 61, you're technically correct. But that's like getting lucky. Like you have two negatives that makes a positive, basically. Or you're subtracting 180 twice and eventually getting it. Yeah, okay, cool. All right, you understand it? Nice. Nice. Nice, nice. Let me save that for you. Yeah, that's... The ambiguous case. Very tricky. And so that's also why skits... I wanted to do the law of cosines. The law of cosines does not have an ambiguous case. You have to be careful with law of sines. I know it's easier, but you have to be more careful with it. If you use the law of cosines, you don't have to deal with that. All right, that was skits number 3. Yeah, just use law of cosines when you can. All right, Millie. Prove the Pythagorean theorem. Do a barrel roll, dude.
Oh shit, not good.
There's so many videos on proving it. Okay. Millie's giving some fun ones here. Which one do I want to do? Millie, I'm going to save all of your questions here. Well, actually, you know what? I will do this one. Wait, what does it mean from the definition of limit? What is this one? Is this the, sorry, the limit definition of a derivative? Or like what? Wait, what? Definition of the limit. Is this like epsilon delta technically? I hate this. Is it epsilon delta? Oh, man. I don't want to do epsilon delta. Millie. Yeah, okay, no. I'm going to leave these for Penn Center because we only have 30 minutes left, and I'll make sure I get through everyone's. But Penn can do these. Yeah, I just don't like epsilon delta. I may look at it later. Let me help out someone else. Z Sigmund. You needed help with just the first one, Sigmund? Is that what you said? Okay. The graph shows the linear functions f of x and g of x. Copy the graph and indicate on the same set of axes graph y equals f of x over g of x. Clearly indicate where any x-intercepts occur. That's cool. Well, here. We know when f of x equals g of x, this means that y is equal to 1, right? That looks like it occurs somewhere over here. I don't really know what we're supposed to like. We don't have like values for this though, right? So, oh, they only want x-intercepts. Okay. Okay. So x-intercepts occur where y equals 0. And y equals 0 here when f of x is equal to 0. So that occurs right here. So, oh, this is kind of fun. They say on the same set of axes. Let me see if I can do that, actually. Let me see if I can copy this real quick. Okay, so let's say this is y. Y will definitely equal 0 here. Asymptotes occur when you divide by 0, which is when g of x is equal to 0. So and g of x is equal to 0 here. Okay, so there's going to be an asymptote there. If we want to talk about the behavior of it, right? Okay. So if we look here, you have f of x, which is positive, dividing by something that's very small that's positive. That's going to be a very, very big positive number. So we could say that the function's definitely going to like... Right here, let's... Sorry, I should make this a little straighter. I want to make it parallel with this. There we go. So the function should do something like this. And then we know it's equal to 1 here. Which, yeah, I don't know if that's actually 1. So maybe we'll put something like here. And then here, okay, this is negative, this is positive. So I think this is going to start doing something like this, maybe? And then this should be doing something like this. I think it's asking just a graph. It said, copy the graph. And then on the same axis, so f of x over g of x. And I think all we're showing here is that, yeah, this is like negative infinity. But then this is also negative. I actually don't know. What can we say about the steepness of these, I guess, maybe? This looks steeper than this, yeah? Because they're not 90. It's actually hard to tell. Because if they have the same slope, then this eventually just becomes asymptotic as well, right?
Nice.
I think this kind of happens, honestly. It depends on the rate of it, actually, right? Oh, thanks for the follow, Poopy.
My man.
How do I do times tables? Practice. I mean, practice is great. I think it might... It depends on the slope of this, honestly. We're not really told that, are we? I mean, the question is this angle equal to this angle? I think they almost are. So in that case, if you had, like... What was it? Y is equal to, like, 3x plus 1. Let's say that one. Let's say this one is y equals negative 3x. Or is this would have to be, sorry. This would be, like, 3x plus 4. Poopy breasticles, breasticles, poopy.
Yeah.
3x plus 1. And then when you divide these, right? So that means, so let's say this is, sorry, this is g of x. This is f. Then y is equal to 3x plus 4 over negative 3x plus 1. And then the limit as x approaches negative infinity, or either infinity, right? That just ends up equaling a negative number. Right, that would just equal to negative 1. So I think, yeah, I think they do this. Assuming they're the same slope. If they're not the same slope, they'll go to some other value. But also, they're both linear, right? Greatest usernames of all time.
Yeah.
Okay. That one's pretty good. Fun question. Download that one. That was Z Sigmund. High five for 100 jewels. Thanks. Thanks, Charlie. Appreciate all the jewels. You guys are great. They do convert. Apparently, like, I saw 1 jewel is 1 penny. Which the penny has not been discontinued. Oh, no. Alright, Z Sigmund was number 6. What was the second question on this one, though? State the domain? Wow. Find the equation of the vertical asymptote. Find the x-axis intercepts. That's actually kind of fun. It's a fun question. Not too hard, Z Sigmund. If you still have questions on that one, ask me. I'll do that. It doesn't take too long. But let's move forward. Boingus. Ooh. What? Excuse me? Sine of x to the x. Determine all x greater than 0 for which the function f of x equals sine x to the x has a local maximum. Oh, man. What's the derivative of x to the x? Is it like x ln of x to the x? Yeah, this is what it is. You can do a cute little expansion with it if you wanted to. How does someone see the question in the queue? So, you can't see it from the admin panel. I should fix that. That's a developer thing I need to do. But on the regular, like, actualofficehours.com, if they click on the live queue here, if you click on any of the usernames, they pop up. Yeah, they should open up in the admin panel, but I haven't added that feature yet. / I'm scared to break it. Every time I start modifying the code, I introduce bugs. Okay, so wait, f prime of x. That would be, this is a chain rule, so derivative of sine is cosine. So cosine of x to the x times d dx of x to the x. So that's cosine x to the x. And then x to the x was x to the x plus ln of x to the x. I heard the last time you vibe coded a bunch of pictures of Shrek. Well, no. Someone found a hole. Someone found a little breach in my vibe coded queue, and so I had to introduce some security features to prevent the unlimited Shreks getting uploaded. The queue now caps at 30, so people can't dump more than 30 questions in it. Okay. Oh, plus, thanks, Machka. Yeah. Sorry, there's an extra XCX here. Dude, what? This is terrible. What? Is that what it is? Yeah, it's a to the x. Wait, what is it? What's the derivative of x to the x? What? Dude, how hard is that just to, like, someone just give me the answer, please? What? Or derivative of a to the x's, I think is what I want. Derivative of a to the x is... Wait, why is there a plus x to the x in there, though? Oh, because you have to do the derivative of a to the... Okay, got you. Is it not? No? You are right here, though. Okay. Okay, I'll trust. I was hoping it was a to the x, and then you just say a is a function of x. Oh, man. Wait, where does this equal 0? So when x to the x is equal to 2m plus 1 over 2 pi. Or x to the x is equal... Well, no, that can never happen, right? This will never be a negative number. Right? Or, wait, but ln of x to the x could be a negative number. No, but then that's always a positive number. Oh, fuck. Or, okay, wait. X to the x is equal to negative x to the x, ln of x to the x. Let's assume x is not equal to 0. Because also 0 to the 0 is undefined, I think, as well, right? So 1 is equal to negative ln of x to the x. So e to the negative 1 is equal to x to the x. Oh, man. Sebastian. So negative ln of e is equal to x ln of x. Negative 1 equals x ln of x. How do you do that? I don't know. Lambert.
Bruh.
Okay, I'm saving this for you, Pen. Pen, you can do this one. Because I just don't want to do Lambert functions with 19 minutes left on my stream. Let me see. Nicola, can I help yours out real quick? You do have a test coming up tomorrow, so I will make an exception. Also, this is physics. Product log my goat. Yeah, that's going to Penn. Penn Center's going to do that on his stream. What's up, Kabir? 4x cubed is equal to 43. That's an ugly one. All right. Find I1, I2, I3, I4, I5. Find the power supply by the voltage sources. Find the power drawn by the resistors. Yay, circuits.
My man.
Nicola, you around? We're going to do this one for you. I know you've been waiting a while. Oh, why is that coming up? I don't need that. W. Lambert, what?
Disqualified.
Yeah. Pen, have fun with this one. Why can't we ever have a nice ground in these circuits? Okay. At least they labeled the currents. But like, Jesus, this sucks. All right, let's do some loops. Loop 1 here. Okay, so that says that 12 volts starting here minus 4 I1. The W stands for what? Minus 3 I2 is equal to 0. Let's do this loop. Node voltage method. Yeah, Nicola is in a very basic physics class, so I don't think they're doing node voltage method. Minus 4 I1. If you want to show the solution with the node voltage method, I'd be curious to see it, Fembox. And then if you're going against the direction of current, you have to add. So that's plus 2 I3 is equal to 0. Dude, there's so many unknowns, bro. There's 5 fucking unknowns.
Surprise, motherfucker.
Get the fuck out of here, dude. What? This is not a test question, dude. What? Okay, and then you can do this one. So 5 minus 2i4. Wait, do we even care about I5? What? We don't even care about I5. Dude, I5 is equal to I4. Right? Thank you, Riley. Yeah, wait. Yeah, I5 equals I4. Now it's only 4 unknowns. Okay, well, not bad, because now we have 3 equations. We need one more thing, and we can do, like, the node thing here, right? So we could say that I1 plus I3 is equal to I2. Or let me do a different color for this. Nice. And then the question, Nicola, is do you get to use a calculator? Or do you have to do this all by hand? It'd suck if you have to do this all by hand. Because I can write this as a matrix. Okay, sweet. So I'll show you how to do this. So you're just going to look at... We're going to do this like I1, I2... I3, I4, and then equals, like, whatever. So in this case, this is -4, -3, and then there's nothing with I3, there's nothing with I4, and then equals 2, you would have moved this to the other side, so that would have been -12. Yeah, dude, I love RREF. She's great, dude. -4, 0... 2, 0, -5. This ends up being 0, 0, 0. Oh, you already get I4 from this, actually. That's kind of nice. -2, -5. And then 1. If you move that over, this is I1 minus I2 plus I3 equals 0. So you get 1 minus 1. 1, 0, 0. Beautiful. It's not the easiest thing to diagonalize. It's not the hardest. But yes, we're going to do this on a calculator. Do you have a TI-84, Nicola? Do you have one of these? Super useful. Because I'm going to make a 4x5. You have a TI-30XS. Oh, oopsies. Well, you won't be able to do this then. So wait. We need a way for you to be able to do this on a test, though, right? Yeah, I don't think you can use. I don't think you can do matrix things on a TI-30XS. Can you get a TI-84 for your exam? You can go buy one at Target and return it the next day. It's probably not the worst thing to solve this by hand. Should we solve it by hand? You want to solve it by hand, guys? Yeah, they are $200. It's excessive, dude. Well, no, they're not that bad. Sorry, if I go to like TI-84 Target, dude, it's 114 bucks. $76 at Walmart. Well, no, Nicola's in an actual class, unfortunately. I have a TI Nspire. Yeah, well, that would be able to do it, but I don't have an Nspire. I fucking hate the Nspire series. I really do not like the Nspire. It's just, I don't know. Boom, boom. Okay, well, then this is your homework, Nicola, is look up how to, like, input matrices in your Nspire and look how to do RREF, because it'll just help you. And I'll show you how it works. So once you have you're gonna put your matrix. Once you've built your matrix like this, you're gonna just put in the values. There's probably some tutorial on YouTube on like how to do matrices on an Nspire. Is it hard to do by hand? I think it is. Let's see. Let me see what the answers are. If the answers are ugly, then yes, it is hard. Just because I have limited time, I'd rather just check to see what the calculator gets first. And then if they're ugly, then you have to do this by hand. I3 is 0. Pourquoi? I4 is easy. I4 is just 2/5. And then, here, let's do REF on it. Let's just see what we get. Oh, so they're not too bad. So maybe we could have done this.
Nice.
Yeah. Yeah. You get 1.5, 2.5, and 2. Okay, so you probably could have. I don't know. See, this is where like I get mad at this professor that Nicola has, because you have to do linear algebra to really solve this. Wow, thanks for the 500 joules.
Yeah.
Wow, that's crazy. I mean, from this one, you can see this only has one missing variable. You can right away say that I4 is equal to 5/2, which is equal to 2.5. I bet it was. But then, wait. I4 equals I5, right, which is also equal to I5. Then how did they get the easy ones here? I guess maybe they did this one minus this one. I don't see it exact. I don't see the... It doesn't look super easy to me. Wait, if you add this one to this one, you would get -2 and then a 1 here. Yeah, I don't see how to do it by hand really easily. The numbers are nice, though. So here, well, see if you can get them eventually. So I1 is equal to 1.5. How come I4 equals I5? Oh, because this is a closed loop. So, oh, interesting. Wait. If I4 equals I5, does that mean I3 equals 0? Ooh. Oh, I haven't posted it in homework help yet. I'll check it out, though. Ooh, so maybe I4 isn't equal to I5. Okay, so I take that back. Wait, what does the I5 do? It's not in any of our equations, at least. Oh, man, now this gets even harder. Because now I have to write another equation. I have to say from here... You're right. No, Jorgen's right. Yeah, you're right, dude. Okay, so from here, I have to say that I4 is equal to I5 plus I3, right? Oh, no. Oh, no, Fembox, oh, no. But I think that's okay, then. Because, wait, I can still use the same values, right? Yeah, wait. Because I4 and I3 don't interact anywhere else. Okay, so I1 equals that. I2 equals 2 amps. I3 equals 1/2. I4 is equal to 2.5. And then, so that means I5 is equal to I4 minus I3, which is equal to 2. Okay, my answers are still right. Okay. Awesome. Okay, cool. Yeah, okay. Cool. All right, those are all the currents. The power supplied by the voltage sources. So, that's just I times V, right? So wait, is this... Yes, okay. So the power for V1... Power V1 is equal to 12 volts times I2. So that's what, equal to 24 watts. The power on the second voltage source is equal to 5 volts times I5. So that's equal to 10 watts. Okay, and then the power draw and all the resistors. Okay, so power equals IV. But if V is equal to IR, they're also equal to I squared R. Yo, what's up? Mathematic fanatic. My dude Waldo, dude. Just want to say you're an awesome person doing an awesome impact on the world. And me.
That's dope.
You're also doing a great job, Waldo, dude. I appreciate your answers in helping out people in our Discord. Penn Center is going to be taking over doing the rest of the questions that got asked here during his stream, actually. So make sure, if you're watching us right now, please go follow us on Twitch. So if you go to the website, actualofficehours.com, go click here, watch live on Twitch. Follow us on Twitch, because then what we're going to do is after this, we're going to raid into Penn Center's Twitch stream. So everyone who's watching us on Twitch will then automatically get to see Penn Center's stream, where he's going to work with some other awesome people on the rest of the questions that I don't get to in the next 5 minutes. Yeah. Another reason to follow us on Twitch. Okay. So, Nicola, assuming you can get this, which, again, I don't really see easy ways to do this by hand. The numbers are nice, I agree. this is then the power in the sources. And then if you want to figure out the power in all the resistors, okay, well, that's just like, for instance, I1 squared R1, and then I2 squared R2, and then dot, 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 dot. It's all the same. So, for instance, for the first one, that would be 1.5 squared times the resistance in the first one, which is 4. So, what is that? 2.25 times 4. That's like 9. 9 watts. And then I think the total power through the resistors has to end up equaling the total power here. Let's see if it does, actually. I'm pretty sure it does. 4 times I2 is 4 times 6. 24 watts. Oh, we're already gonna be over, though. Fuck. Wait, what? Yes. The algebra would take way too long on an exam. That's why you want a matrix. 100%. Wait, no. R2 is 3. It's 12. I3 squared. Yeah, this is 2 squared times 3. R3. So I3 was 0.5 squared. So 1/2 squared times resistance 3, which is 2. So 2 times a quarter is 1/2 watt. It's not that arcane, Fem. It's just not taught. Nicola is a life science major. She's like a pre-med, like bio person. And so the fact that they're doing like this intense of a circuit for like it just doesn't make any sense. There's a little bit. I understand if this was a physics major or engineering major class, it would make sense to me that they were asking these things. 2.5 squared times R4. R4 was 2. What is so is that 12.5 watts? I think so. 6.25 times 2 is 12.5. And then I5 squared R5, that's equal to 2 squared times... Oh, but there is no R5. Oh, beautiful. So we don't even need it. Okay, so there was no resistor 5. I don't even want to go to med school. My major just requires it. I really just don't understand why I need it for psychobio. Yeah. You should take some physics for psychobio, but not like engineering level. I agree. So this is 21. Oh, sick. Plus 13. 34 watts. Wow, total. Nice. We did it. Cool. Love it.
That's dope.
The end is right there, champ. Thank you, dude. Okay, nice. And that's the total power. Well, oh, yes, that's the total power. 34 goes 34. Check. Nice. All right, let's end out the stream. Okay, cool. All right, thank you, everyone, for coming to Actual Education Office Hours today. Really appreciate all the questions. Had a lot of fun ones from y'all in the chat. All right, I'm going to mark this one as done so Penn doesn't have to do it as well. Great. So, yeah. If you just found us right now or in the last, like, 2 or 3 minutes, or you've been living under a rock, please make sure you go visit our website. It's actualofficehours.com. There you can upload screenshots of homework questions you want us to do live during the stream. And you can also figure out all the times we're streaming by clicking on streaming schedule right here. This has a calendar showing all the times that we stream and all the times our awesome friends stream. So we do not have a stream tomorrow because I have to go DJ a physics conference. I'll explain later. But yeah, so I'm out tomorrow. But Zach will have a math help stream in the morning. And then Penn Center is doing Riemann surfaces. Cool little lecture. Yes, thank you, Master Mugu. I would love to. I'll go check it out. Thanks again. Also, join the Discord if you can. So here, if you go to join our Discord, that's the best way for you to go see all the questions that we work on throughout the stream. So here, for example, you can see that there's a channel called Homework Help, and every single question we've done here has its own little post. And then we'll either try to solve it, and if we don't get to it, ChatGPT will go through and solve it. So make sure to join the Discord. It's a great way to get help with your questions, even when we're not here. And also make sure you go follow us on Twitch, because what I'm going to do now is we're going to go raid Penn Center on Twitch which means everyone here is going to go to Penn Center stream, and Penn Center is awesome and has volunteered his time to work on the rest of the questions that are in the queue that I have not gotten to. So, yes, have a good night, everyone. If your question's still here in the queue, do not worry. Penn Center is going to try to go through them as well on his stream. So make sure you're just following us on Twitch. And what we're going to do here is we're going to go raid Penn Center stream, and then he's going to do some casual homework help. Cool? All right. Awesome. Okay. Thank you, everybody. Have a wonderful rest of your Tuesday. We will see you on Thursday. Peace.
And if we do some rearranging, like I think we can rearrange and kind of group some stuff. So we get like 4x squared minus a squared x squared. So that should take care of that and that. We have a minus 5x minus 2abx.
Brace yourselves, everyone.
Is that how that's going to work? And then we have a 1 take away b squared. Hello, writers. Welcome on in. Welcome on in, Dr. Gold. Hopefully your homework help stream went really well. My name's Penn Center. We're going to continue on the fun for a little while here. Hey, Clickbait. How's it going? We're going to do a little math homework help tonight.